All right, we're going to look at the first free response from review day 14. It is a ton of different functions and lots of different information. So we got to really navigate well through this problem. A says find the slope of the line tangent to f. F is given to us as here at pi x equal pi. So we first have to take the derivative of f, which is negative sine 2x times 2, so negative 2 sine 2x. Plus e to the sine x times the derivative of sine, which is cosine x. Okay, so that's our derivative of f. Then we're putting pi into that. So when we put pi into it, we're going to get negative 2 times sine 2 pi, which is 0. So I'll just write this here. F pi is 0 plus e to the sine of pi. That's equal to 1 times cosine pi, which is also 1. So I get 0 plus 1, which is 1. So they gave you a point for that derivative and a point for calculating it out to be 1 there. All right. B says let k be a function defined like this. What's k prime pi? So this is a chain rule. K prime would equal h prime and leave f alone times the derivative of f. Okay. So if you had that, that was worth a point. And then k prime of pi would be h prime of f of pi, and we'll write that in, times the derivative of f at pi. Okay. Now, f of pi, if we put pi in, we get cosine 2 pi, which is 1, plus e to the 0, which is 1. So this is going to be 2. So we're going to have h prime 2 times f prime of pi, which we found in part A. F prime pi was 1. Okay, so if I come over to h and I look at 2, the derivative of h at 2 is the slope of this line, which is a negative 1/3. Okay, and so if you had the derivative point, if you got down to here correctly, that was worth another point. Okay. Now, C says let m be a function given by g of negative 2x times h of x. Find m prime. So this is a product rule with a little bit of chain thrown into it. So we'll do that here. C is going to, m prime is going to be the derivative of g, which will start off as g prime, leave negative 2x alone, times the derivative of negative 2x, which is negative 2, times h of x as is, plus g of negative 2x times h prime of x. Now, if you correctly got through that, they gave you 2 points for all of that. All right. Then they want the derivative at 2. So that's going to be negative 2 times g prime of negative 4 times h of 2 plus g of negative 4 times h prime of 2. All right. So you got a lot of different things to kind of work out here. If we put, now g prime negative 4 is given to us in a table. Up here, g prime negative 4 is negative 1. So this is going to be negative 2 times negative 1 times h of 2. h of 2 is negative 2/3. And that's real sneaky because of the slope going down. That's not something we would do very often, but that's what that value is. Okay. G of negative 4, according to the table, is 5. And h prime of 2 is what we found in part B. That's a negative 1/3. Okay, so putting this all together, we've got negative 4/3 and negative 5/3. That gives us a negative 9/3, which is a negative 3. If you got all the way to there, you got another point. Okay, again, 2 points for the derivative, 1 for all this kind of extra work. All right. Then the last question says, is there a number c in the closed interval such that g prime c equals negative 4? So that's that mean value theorem idea, right? So let's look at the average rate of change on this. So we know that g is continuous and differentiable. That's important in order for us to use mean value theorem. And g of negative 3 minus g of negative 5 over negative 3 minus negative 5 is equal to 2 minus 10 over, and this is going to give us 2, which is negative 4. So mean value theorem guarantees a value in this interval where the derivative g prime x or c equals the average rate of change. Right? Or something to that effect. For this here, you got a point for working out the average rate of change, and then again, I think you're going to have to say continuous differentiable for the mean value theorem, but something along that line will give you the other point.